Good evening. Welcome back to our channel, Art of the Organic Synthesis. So in this particular video, I have taken some questions from this previous year of CSIR, and the marks of each question is the 4 marks. So this lecture is going to be very much effective for you. So stay tuned with me. The first question, this question came in December 2016. So what was the question? We have given this compound, and which is nothing but just a spiral compound having the cyclopropane and epoxide ring treated with H positive ion. So you always think that whenever oxygen has the lone pair of electron, the H positive ion is stacked here, and I'm going to make here what is going to happen here. So 1 second. Okay. So this is the epoxide ring, and this is our cyclopropane system. Okay, and now this is the positive charge. So always keep in mind, if you want to be a good organic chemist, you see the all possibilities. So the way I am doing the question, you have to see apply the same techniques. Like how can you eliminate the 4 option? So first thing is that we make this thing. Now we have to check all possibilities. So either I can take this one like here, and I can take from here. So both possibilities are there. So this is my first possibility, and this is my second. So I am taking the path second, and this is your path first. So you can see here, if you go from the path number 1, so what you observe, this, this, okay, and OH will be this side, and we get positive charge here, okay. So you have to see this thing. What happened? There is the angular stain is there. So I am clearing this stain, angular stain. So what is the angular stain? First we will see there. Wait a second. Okay. So what is the angular stain? So with that, we know that this is the ideal tetrahedral molecule. Okay. So in tetrahedral molecule, what is the bond angle? This is the 109.28 minutes. So what is the angular stain? So any molecule having the sp3 tetrahedral geometry. So the deviation from the 109.28 degree bond angle, so that is called the angular stain. So look at this molecule. So cyclopropane system is 60 degree of bond angle. Okay. So what can is there if we subtract from here? So 60 degree, we are in degree 49 degree and 28 minute of bonding angular stain. So this cyclopropane in contain 49 degree 28 minute of angular stain. So this is very much unstable. And second thing is that we are making a positive charge here. If we make positive charge, the hybridization will be sp2, and sp2, that means bond angle is 109 120 degree. So what happened? So again we are increasing the angular stain. So that means this carbocation is not going to be is not stable. So what we observe here, the path number 1 is not favorable. So according to path number 1, what will our option? So according to path number 1, if we see, the option number C is correct, option number D is correct. So we seen here, due to angular strain, this part is not favorable. It means neither C or nor D. Both options will be eliminated. So if you are getting 100% accuracy in organic chemistry, you have to see about how can you eliminate the maximum number of options. So in out of 4 options, we eliminate C and D. Now talk about the A and B. So A either A may be correct and B may be correct. So how can we talk about this thing? We have to know about the complete mechanism. So let's see. I choose path number A. So in path number A, what happened? So this, and positive charge will be developed here. So what happened? Now this positive charge is very much stable. Why? This is called non-classical carbocation. So why this is stable? Because this cycling this is called the banana bonding. Takes place between the cyclopropane and out all of the three bond, each bond can be migrated here like this. So we have to increase the decrease the angular strength. So this bond can go like this. So what is our final product? So we end up with, if we numbering here, 1, 2, 3, and 4. So we have a 4-member ring like this, in which in 4 number there is the this thing, and in first number we have ending with 4 positive. So if we replace this H positive and from here, so this is called this correct answer. Okay. So what is our correct option is there? So option number B is going to be correct. So we can think here. So in option number B, this substituent and carbonyl group both are the 1,2 side. So this option is going to correct, incorrect, and we are getting in with option number B. So this is the way in which we got the what you can say then. This is the way in which we get the correct answer. Now next question is came in CSIR June 2017. So in first step again, oxygen has the lone pair of electron. This lone pair electron is taken by this hydrogen atom. So we have positive. Now this bond can migrate like this. Positive side. Again, so this cyclopropane system, what happened here? In this cyclopropane system, to see cyclobutane. So cyclobutane internal bond angle is 120 degree, and our standard bond angle is 109.28 minutes. So in this molecule, how much degree of angle is 10? 19 degree and 28 for angular strength. The molecule has to reduce this angular strength. So this bond is going to be break. And if we break this bond, so we end it with this molecule. This thing. So this bond is going to break. So what happened here? If we look closer, so this bond is connected with this one. That means this is the positive charge generated this end. Now what happened? So this bond can break here, and again this is the rearrangement takes place. In which 1, 2, 3, 4, and 5. So two 5-member ring which are spiral to one another. So this two 5-member ring, and we are entering with this compound. So now question is that, so this is option number A and option number B is not correct. Now think about C and D. C and D, how can we differentiate? So this connected this one is pair of 1, 2. So this is pair of 1, 2, and this is pair of 1, 3. So pair of 1, 3 is not correct answer. Pair of 1, 2 is for correct answer. So this is the way you can get the correct answer. Always think about the how can you eliminate maximum number of answers. Now this question came in again CSIR, and this is simply, if you look here, so SN1 and SN2. So you always think about what is the mechanism of SN1 and SN2. In SN1, we have to see if we should have polar protic solvent, and SN2 polar aprotic solvent. So H2, what about the H2? The H2 belongs to the polar protic solvent. So in polar protic solvent, so SN1 reaction will be takes place. So what is the option here? So I'm going to erase all this. So SN2. H2 is the polar protic solvent. The polar protic solvent going to SN1. So means SN2, SN2. Both option will be eliminated. Now we have to check either this one or this one. So if SN2 reaction will takes place, so what will happen here? This is the formation of the carbocation will takes place. Okay, so we have this hydrogen here, and second is the hydrogen here. Now this bromine and this is the now this bromine is going to be positive. So now this center is the planar. sp2, this is the planar. So nucleophile has chance it can attack from the above and it can attack from the below side. So what happened here? We are getting in with two compounds. The racemic compound is there, so sp2 geometry is there. I can move more clearly. I can make here. So suppose this is Me, Me, and Me, and this is the sp2 hybridized carbon. So sp2 hybridized carbon is the carbocation is the vacant p orbital. The nucleophile has chance either it can take 50 from this side and 50% from this side. So we are ending with the racemic compound. So we cannot fix the stereochemistry here. So we cannot say that this is perfectly going to be the alpha phase, beta phase. So beta phase is not 100%. And if we make this wag bond, that means some of the molecule is above and 50% of OH is above and 50% OH is below. That means this is a racemic product response. So option number D is not correct answer. So we are ending with option number. This is our correct option. Now this compound, the question asked in CSIR June 2018. So I will draw the mechanism first because it is hard to say what is the correct answer. So I start with the mechanism draw. So this is methyl. In first step, what we have given LDA. LDA is the hindered. So LDA lithium diisopropyl amine. So this is hindered base. What can they? It abstract this hydrogen like this, and this bond can be open. So we have pH double bond, and this is cyclopropane system, and this is O negative. Now this O negative, what can attack here? We have TMS here. Si Me3 here. So this attack on this dilating atom and make this compound. Or TMS. Now in next step, what happened? This cyclopropane again, it has angular state. Now you are habitual with the angular state, and you can easily tell that it is a 49 degree and 28 minute of the angular state. So this is going to be break here. So what is the driving force? So this can be go here, and this make the so sorry. So this bond can attack here and like this. So what happened here? We are into this 5-member compound and double bond this thing. So if we heat this molecule, so this cyclopropane will open, and we are ending with I think this thing and having this pH. So I start with 1, 2, 3, 4, and 5. So this is 2. So this one is going to be first. So first, second, and so what we see here. So this fab 50 can be connected here, and 2 and 3 connected with double bond. Okay, and this OTMS group also is there. So I can say that this is the driving force, and let me see what happened here. This is SiMe3. So after the hydrolysis, this H2O attack on here, and this post protonated is like this. So this can be go like this, and we can make pH and OH, which is after tautomerization, we are ending with pH and W. Okay, so this is our compound. So according to this, what we going to our answer? Okay, so 5-member ring. So in first option, 4-member ring, this is not correct. 4-member ring, this is not correct. So 5-member ring, option number B may be correct, or option number D may be correct. So till now we have solved the 50% of the question, and in 50% question we have observed that 4-member ring is not going to be formed here. We are ending with the 5-member ring. So now what happened in the next step we will see. So I am erasing to all steps. So we are ending with 2 compound. So this is called if we would have a carbonyl compound treated with MCPBS, this is known as the one of the famous name reaction Baeyer-Villiger oxidation. Okay, what is the structure of MCPBS? This is the meta perchlorobenzoic acid. So this is meta perchloro. So this is called MCPBA. What is the full form? Meta perchlorobenzoic acid. Okay. So now let's see quickly the mechanism. So we have this let's say this thing. So I am consider this in the R. So now this bond can be migrate from here, and this bond going to be attack here. So what we are ending with, we are ending with this compound. So according to this, what is our answer? So phenyl O and phenyl are 1,3. So O and phenyl are in the correct answer. O and phenyl are the 1,3. But in case O and phenyl are the 1,2. This is not going to correct answer. That ending with option number D. So this is the way you can get the correct answer. So why this has happened? Because this is the phenyl magnetism will take place. So always keep in mind magnetic group aptitude. You have to think hydrogen, then pH, then alkyl. Now next question. This is came to December 2018. So this is again one of the good questions. The first thing we can see here, what is this thing? So we have this thing. treated with air Cl3. Now this chlorine is lone pair. This is treated with this thing. So CS3 double bond AlCl3. So this make negative, this can positive. Now this has the lone pair of electron. This can come back and come back. So we are ending with selenium ion. Okay. Now we start our mechanism from here. We have cyclooctadiene, and this is CS3 C triple bond O positive. So this is the kind of the electrophilic addition reaction. So suppose that is CS3 going to attack here, make a positive charge here, and again we have a double bond here. Now we have a chance to attack on the center. So if say double bond has size, either this end will attack here. So if we start from here, so I can make A and B. If this A attack here, so B. So if A attack here, so what will happen? This is the compound like we can end up with 1, 2, 3, 4, and 1, 2, 3, 4, 5, 6. Like this. Okay. So we the positive charge is developing here and this thing. And 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5, 6. So happen here and we are getting this compound. And this positive charge attacked by the Cl negative. So I'm not going to further. And if I see here, okay, if I choose path number B, so in path B, what happens? This B going to attack here. So 1, 2, 3, 4, and 5. Again, 1, 2, 3, 4, 5. So we are ending with the 2 5-member ring are going to be fused. Okay. So 2 5-member ring are going to be fused. Now, in second person, we have this is bridge position 1. In second person, we have this thing. And if we see here, so this is condition of the positive charge. Now this Cl negative can attack here. So this Cl and this is the CS3, CS3. Okay. So what happened here? So option number A. So if we consider the answer, so option number A not possible because the first elimination takes place. This is also not possible. And if we see, so this is 4-member ring, which is considered to be 19 degree of 28 meter of angular strength. So this is not going to form. So we are ending with only option number C, which is our correct answer. Now this is the bonus question from my side, and this is one of the important reaction. This is not the fumarate. So this is fumarate rearrangement, and this question came in CSIR December 2018. So what is the beauty of this reaction? So first thing is that we have MCPPA, and same thing is there. Carbonyl with MCPPA is going to be Baeyer-Villiger oxidation. But thing is that we have here sulfur atom. So always keep in mind whenever you have selenium, sulfur, and all these things. So and you have alkene and carbonate. The MCPB region always going to be first oxidize the sulfur atom and this selenium oxide. So we are not going to the Baeyer-Villiger oxidation because some of the guys if make the Baeyer-Villiger oxidation, so they are ending with option number A. But this is not correct answer because here Baeyer-Villiger oxidation will not take place. We are starting with the MCPB first oxidize this sulfur atom. So what is the final first option? So this our compound. So carbon is not going to oxidize. Who is going to oxidize? Sulfur. So we have one equivalent, so we can end up with this question, this sulfoxide. So sulfoxide will come here. Now, second thing is that we have Ac2O. So actually this sulfoxide, how can we make this? If we clearly written here, sulfoxide is nothing but this thing. And we have Ac2O. So Ac2O is nothing but this thing. Now this is nucleophilic in nature. This can attack here, go like this, and like this. So we are ending with and we are here OAC, and this is the positive charges generated here. Now again we left with the minus OAC, which is act as a nucleophile or act as a base. So we have this H atom here. Now this OAC come here and attack on this hydrogen, which is called like this, and this OAC can move from here. Okay, now this one. Now we have aqueous sodium bicarbonate. So in aqueous sodium bicarbonate, if we see here aqueous sodium bicarbonate, so this aqueous sodium bicarbonate contains some amount of the H2O. So now H2O is going to attack in this reaction. Like this, and after that if we have some amount of this thing, so after the workup this can go here and go here. After the workup this attack here, this can go like this. We are ending with this compound. So according to this, what should be our answer? So this option is not correct, and in this option what happened is they provide just nothing to do. Option number C is also not correct. Now we have choice option number B and C, but in aqueous condition little bit amount of the H2 will present, so that will remain at eliminate this HPH and we are ending with this dicarbonyl compound. So option number D is going to be that. So in this particular video, I have covered five questions and the pulmonary arrangement from my side. This is the bonus question, and this is one of the important questions. And GATE examination asked 2-3 times from this particular name reaction. So read this about this name reaction. This is one of the important name reaction and going to be very much confused. So I hope you like this video. Thank you.